Let's start reviewing for our Unit 14 test. I figured a video would probably be our best bet just because it's a huge packet and I don't know if I'll have time to do it all in class. So it does say to use our calculators on numbers 1, 2, and 3, so I'm going to grab a handy dandy calculator. The first question is actually way down here, and it says to find the value of P. As you can see, I've already written on this paper. That's because I started it and then had to stop the video, delete it, and start over. But anyway, we're going to find the value of P. And as you can see, I already have the answer there, but P is going to be a 0 of this function. So what we're going to do is we're going to go to y equals, we're going to type it in, x raised to the 4th plus 54, nope, man, I'm bad at this, 54x squared plus 60x. We've restricted the domain from -1 to 6, so go to your window. X minimum is -1, x maximum is 6. The scale of 1, yeah, that'll work out. Now, y minimum, this is a quartic, a 4th degree polynomial, and it has large coefficients. So there's a really good chance that this number is super far down. So let's just go to -500 from experience. I know that that's probably going to be big enough. And up, it's probably not very high. I mean, if that's 500, that's pretty small. 50? Sure. And let's make our scale go by 25s. I don't know. Let's see. Okay, yeah, that worked out pretty well. It's pretty close to what's on the graph. Well, anyway, we're supposed to be trying to find that point, which is a 0. So I could just use second trace 0, but I would rather set the second line equal to 0 and do second trace intersect. It's just a little bit faster. Second trace intersect is 5, because then I can just say yes, yes, and scroll over to the answer and hit enter. And it's going to give me the x coordinate of 1.138, which is why I have 1.14. The second question says to write down the coordinates of A. Well, A is a maximum value. So again, there's more than one way to do it, and I could do second trace maximum. But because it's a calculator question, no, wait, what am I talking? I am going to do second trace maximum because it's a calculator question. There we go. I could have done the first derivative and tried to set it equal to 0, but it's just not worth it. Gonna wait for it to graph one more time. Second trace max. And maximum is a 4. It says left bound, so I'm going to scroll to the left of the answer. Yeah, that's to the left of it. Then go to the right of it a few times. That's pretty good. Then go somewhere in the middle. That's pretty good. And it's going to give me my maximum at 0.562, comma, 16.8. And ta-da! There it is. I've already got that going on. Now, the real reason why I deleted this video and started over was 1C. It says to find the equation of the tangent to the graph of f at A. And you see, what I did was I immediately went to derivative, then I went to plug it in, and then I thought, wait a freaking second. We just said that that point's a maximum. And the slope of all maximums is 0. So this thing's equation of its line, the tangent line, is a y equals, and it's whatever y equals at that value, and we already know it. It's 16.8. So the answer for this is y equals 16.8. Now to find the coordinates of B, though, which is an inflection point, according to the description, we're actually going to have to go all the way to the second derivative, because inflection points are found when the second derivative equals 0. That's not true. When the second derivative crosses through 0. So let's find our first derivative. 4x to the 3rd minus 108x plus 60. Now we'll go after our second derivative, and we will figure out where that equals 0, because all inflection points will occur when the second derivative does equal 0, but it must also cross through in order to be an inflection point, which usually means sign diagram. Let's see. Bring the 3 down, we have 12x squared minus 108. Okay? This is going to be equal to 0 in two places. Let's factor that 12 out. Actually, you know what? Let's not even do that. Let's add 108 to both sides. Divide by 12 and take the square root. Remember that gives you a plus or minus. So we say 108 divided by 12. And, oh, look at that. It's the square root of 9, so it's going to give me plus or minus 3 when I take the square root. Here's the thing. Negative 3 is not within that span. So when I make my sign diagram, I throw a 3 on there somewhere, picture not drawn to scale, and I'm hoping everybody can see that to the left of B, this thing is concave down, and to the right of B, it's concave up. So this x equals 3 has to be my B value. It doesn't have a choice. It's the only time the second derivative equals 0 in that span. But I might as well finish filling out the sign diagram. Plug in like a 0. You get 0 minus 108, clearly negative. Plug in a, I don't know, 4. Well, 12 times 16 is a lot bigger than 108. So when you subtract, you're going to get a positive. And because my second derivative switched sign at that value, yes, that is definitely an inflection point. We know it's at x equals 3. 3 comma what? Well, you would plug 3 into the original equation. And if I remember correctly, yes, the original equation is still graphed. So I could just do second trace value. And it says, well, what x did you want to plug in? I go 3, and it goes, okay, yeah, that's going to be at y equals negative 225. And the last part says to find the rate of change at B. Rate of change is f prime. It just wants to know what is f prime at 3. So that's going to be me plugging 3 into this equation. So 4 times 3 cubed minus 108 times 3 plus 60. We could see it better be a negative number because this graph is decreasing here. I don't know what 4 times 27 is off the top of my head. (108 minus 324 plus 60 is negative 156. Wow, that is an extremely steep line. All right, but number 1 is done. Number 2 is quite the wacky graph. It says we have a second derivative of something. This is the second derivative. We know we're only going between 0 and 1. It says sketch that graph. Don't break your brain. It's a calculator question. So go to y equals, clear out the old one. I have cosine of 2x times sine of 6x. Go to our window and basically copy this thing. My x minimum, I'm going to follow the domain. My x minimum is going to be, actually, you know what? Let me follow this, and then we'll talk about that in a second. X minimum is negative 0.5. X maximum is 1.5. And this scale is wacky. Look at this. 1, 2, 3. They cut this 0.5 into fourths, which is weird. What is 0.5 divided by 4? Is it 0.125? I think. Sure. Then my y values go from negative 0.5 all the way up to, well, I don't want to say 1.5 because they've added another, whatever 1.5 plus 0.125 plus 0.125, that's, I think it's 1.75. We'll see. I wish the graphing calculator had numbers on its axes. You have to be careful though, because you were only allowed to go to x equals 1. So you have to start at x equals 0, and we can see it crosses through the origin at x equals 0. And I want to know where is it at x equals 1, so I go second trace value, and I plug in 1. By the way, never graph in degrees. Okay, at 1, I'm at the y value of 0.11, which is actually a little bit less than 0.125, so that's like right here-ish. I'm not going to go to the left of this dot or to the right of this dot. Now I just have to sketch what's going on in between here. I want to know where this maximum is. I want to know where that maximum is. I want to know where these two zeros are. So second trace max. Left, right, between. All right, I got a maximum at 0.234, which is a little bit less than 2 of my tick marks, comma, a little bit less than a little bit less than 1, 0.88. My tick marks, man, I wish I could see numbers on this. So 125, 0.88 is like right here-ish. Sure, it's a sketch. Second trace minimum, which is 3. I'm going to go to the left of this minimum. Going to go to the right of it. Going to go in between them. About 0.64 comma itty bitty. It's not really super accurate, but whatever. 0.125, so this would be 0.625. It's a little bit after that. It's like right here. Something like that. And the last one, maximum. Sorry about the cough. Almost to 1 and about 0.185. That is above. So it's something like this. Now let's find those two zeros. You know what? Go to y equals, graph another line, second trace intersect. Yes, yes, and then get close. First one's at about 0.52. Second trace intersect, which is 5. Yes, yes. Second one is at 0.785. That's like right here-ish. It's a sketch. Okay. So what did we say that first one was? That first one was at 0.52. Crap, I'm going to have to write it down again. I'll find it again in just a second. There, it looks something like that. And let's see. Second trace, 5. Yes, yes, guess. Let's see, scroll back to it, see where it was. 5 to 4. Okay. All right, let's see what we got going on. So there's our sketch. That took significantly more than 3 minutes, but I wanted it to be a super accurate graph. It says find the x-coordinates of the points of inflection of the graph of f. Uh-oh, I have to pause the video. All right, back to recording. Sorry if the picture jumped. I don't remember where the paper was when I paused the video. Anyway, it says find the x-coordinates of the points of inflection of the graph of f. Be really careful, please. This isn't f. This is f double prime. Points of inflection happen when f double prime goes from positive to negative or from negative to positive. So when it says find the x-coordinates of the points of inflection, they're right there. That's it. Those are the answers for 2b. Okay? So for 2c, when it says to find the values for x when the graph is concave down, remember what concave down means. Concave down means the second derivative, which here's our graph, the second derivative is negative. The second derivative is negative when the second derivative is below the x-axis. It's below the x-axis literally between those two numbers. So between 0.524 and 0.785. Don't overthink this one. There. Number 2 is done. Number 3, new polynomial, says there are 2 points of inflection on this graph. Write down the x-coordinates of those points. All right, well, points of inflection are, I almost goofed up. This is f prime. It says there are 2 points of inflection on f. So what we need to do is find f double prime. Bring down to 3 gives me negative 72x squared. Bring down to 2 plus 18x plus 3. And it makes sense that there's 2 points of inflection because this is a negative quadratic. And it's probably going to cross the x-axis twice. Oop, calculator turned off. Negative 72, oops. Go away. Go away. Negative 72x squared plus 18x plus 3. This is going to be a very steep quadratic. I wonder, I'm just going to hit zoom 6. Oh, okay. Well, I mean, it fit on the screen, but those two numbers are really small. I'm just going to adjust my window to make this graph easier to look at. My x's do not need to go that far. I'm thinking like -3 to +3. And my y minimum, that was way too far down. So like -5, that'll do. And my y maximum was way too far up. I'll just take it to 5. Let's hit graph again. That's better. We can work with that. This is the graph of the second derivative, and you can see the second derivative, it passes through the x-axis twice. That means it has 2 places where it changes sign. Negative to positive, positive to negative. Those are both inflection points. So y equals 0 graph, and we will just find our 2 zeros with second trace intersect. Second trace intersect is 5. Yes, yes. Scroll. There's one of them at x equals negative 0.114. It says the x-coordinates. Let's find the other one. Second trace 5, yes, yes, scroll, enter. 0.364. There it is. This one says, now we're going to define a new function, g of x, and we're going to say that g of x is f double prime. This question says, explain why this graph has no inflection points. We don't even need to know what its equation is. We can just say this. G prime of x is linear. See, that would become a power of 1. Linear graphs, they can only cross the x-axis once. So G double prime of x is a horizontal line because it's going to have a slope of a positive number. How do you spell this word? Horizontal. Horizontal lines don't cross the x-axis. They are either above it, below it, or on it. And you could see that the second derivative would be negative 72 times 2. Which is below the x-axis, does not cross x-axis. And since the second derivative does not cross the x-axis of this, second derivative of this, the second derivative of this does not have any places where it changes sign. So no inflection points. That'll be the first video.